situation with the suicidal thing, you know. And when I was a kid, people always told me what I couldn't do, you know. And to this day, it pisses me off because everybody always told me what I couldn't do. Nobody told me, like, give me guidance on what I could do. And half the stuff I've done, I never would have been able to do it. And I didn't think I could until someone said, you can't. And I said, wait, I can't. And I said, well, maybe I can't, but I sure as hell gonna try, you know. And that's the whole reason why we're here right now, you know. We started off in our kitchen. The first time when we were playing, people were, what are you gonna do that? No one's gonna like what you're doing. That's like, okay, well, if we're wasting our time, let us waste it. You worry about your time. Sometimes you gotta fight with your fist, sometimes you gotta fight with your mind. And that's the whole reason why we're here right now, you know.
Hello and welcome once again. La, 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 la. It's me, Miss D, your host, filler metal. So, okay, now that you have the basics, let's dive deeper into understanding of the electrodes. A while back, the American Welding Society developed F groups or F numbers. These names are kind of used interchangeably. In the past, F numbers were used to tell the welder how difficult the electrode is to weld. Well, F numbers actually surpass the first couple that we know, and I believe the chart goes all the way up to F99. The F numbers group the electrodes by the characteristics of the rods and the type of flux coating. The first four F groups, though, they actually have names. They named them. So that means, hey, something pretty important. So the first one is called F1. This is the fast fill, meaning the electrode has a high deposition rate. And these rods are usually called jet rods. And if you notice, the groups are with characteristics like flux coating, how they work overall. And this chart also shows the required polarity. And it'll even show you the position that you can run it in. So F1 group can only be welded in flat and horizontal fillets. All right, F2. This is the fill freeze group. So these rods are partially quick filling, but partially quick freezing, or the puddle solidifies quickly. F3. Here's my fast freeze. In these rods solidify quickly. So E6010 is in this group, and E6010 is usually used for open roots because the weld pool freezes quickly without sagging. F4, or fill freeze. This group is the second fill freeze group right here. Okay, and as the characteristic is partial to fill quickly and freeze quickly, it's grouped like this because of the flux coating. Now, the flux coating is low hydrogen for F4, and usually we're going to use this on structural steel to combat cracking. Okay. Alrighty, okay, so let's look at some of the carbon steel electrodes you might run into. The first one, E6010. This is a deep penetrating rod that is part of the F3 group, so it's a fast freeze rod. This rod is generally used for open roots because the puddle freezes quickly. This rod is usually used for pipe welding for root passes, and this rod must be used with a whipping motion for gas expansion. This rod can also weld over paint, grease, rust, and dirt. Okay? The flux assists us by bringing those impurities into the slag, and as we can see by the picture in the left, the penetration. So here's our penetration of E6010. It's pretty deep penetrating. Now the next one is E6011. Now this rod can be used on AC. So this is kind of a substitute for that home welder who only has an AC machine. So if we can see, 6011 is still pretty decently penetrating, but not as much as an E6010. Okay, now we're going to look at 6012, 13, and 14. 12, 13, and 14 are all grouped in the fill freeze group. Now the penetration is a lot less, and there's some changes to the flux coating, but most will run about the same. Most of these rods are used for sheet metal fabrication on thin materials. Okay, so we can actually see the penetration here, and it's not as good. And if we keep going, here's a 14. Now remember, this number here, this is only tensile strength, so this number can change. So when we're comparing electrodes, don't let the tensile strength throw you. We just talked about 12, 13, and 14 rods. But on the slide before, we saw that it was a 60,000 pounds and not 70,000. So remember, when they're grouped by the way they weld and not their strength. So we know that the penetration is light because of the grouping with 12, 13, and 14, okay? E7024. Now this rod, this falls into the fast fill group. This means that the deposition rate is really high because of the type of flux. Now these rods are the jet rods because of how fast they fill. So in order to run these rods, you just drag rather than manipulate it anyway, okay? The drawback is to these rods is the 2. What do you mean by the 2? The 2, okay? We're looking at the 2 here. Well, what does it tell us? It tells us position. How can we run it? So we know that the 2 tells us this rod can only be ran in flat and horizontal fillets only. So it can change what we're trying to accomplish. All right, E7016. Now this rod, it falls into the F4 group, or the fill freeze. And this is the same group as 7018. This is a low hydrogen group. And these rods were designed to help with sulfur that's in different types of metals. Now, 7018, funny. This is the only rod they decided that they needed more information on. So E7018 falls into the what group? F4, fill freeze. This is a low hydrogen rod to help with sulfur. Ding, ding, ding. So in order for these rods to work their best, they can't be exposed to moisture for too long. So there's some specific requirements when welding this rod according to AWS D1.1. So after 4 hours, these rods must be baked in an oven to remove their moisture. Now these electrodes are more commonly used on pipe and plate for structure buildings, shipbuilding. A lot of stuff is done with 7018 rods. So I wanted to show you kind of a comparison of the weld bead profiles as well as the penetration. So right now it might seem like a lot of information, but it'll start to make sense after a while. So we can see, oh wow, look at how deep penetrating some of these are. Wow, look, 7018 really isn't as deep penetrating as I thought. Wow, a 7016 is a little bit more. All right. Carbon steel. So you see something like this. What does it mean? Well, the XXX, those are the placeholders for the tensile strength and the position. So then you'll notice something. It says DCRP or DCSP. Well, DCRP or DC reverse polarity is just the same as DC electrode positive or DCEP. Now when you see, wow, okay, DCSP is DC straight polarity, and that is just the same as DC electrode negative. Okay, so we can also add a suffix, the end. Okay, so for example, it indicates it is a 0.5% of molybdenum addition to the weld metal desired. So if we look here, I can add these suffixes and it tells me what I'm adding. Okay, rather than give me another list of information.
Stay tuned for another part.
Weld the world.